Okay, the one new thing we would have done today or yesterday, if I had seen you either day, is transformers. And I gave you these notes. They're on the back of the page that we've been using. Okay, so if you want to find those notes, that would be a good thing. A transformer is really just a device that transforms or changes. And what it transforms is voltage. So it transforms or changes the voltage that is being put into it so that the voltage that comes out of it is different. And really, it's using alternating current, okay? And most transformers have an iron core. So this would be iron. And they're composed of two coils of wire. So we have a coil of wire wrapped around this side of the iron core, and this one would be called the primary. Okay, the primary coil. And then there's a totally separate coil of wire wrapped over here, and this one would be called the secondary coil. And I purposely made the number of lines I drew on the primary different from the secondary. The primary coil one is hooked up to a voltage source. And not any voltage source, it's hooked up to an AC voltage source, an alternating current voltage source, so that the current that's flowing in this coil is changing. Remember, alternating current is sinusoidal. So the current flowing here is changing. The changing current then is going to have a magnetic field around it. Because it's wrapped around this iron core, where this other set of coils is, this other set of coils is not hooked up to a power supply. It might be hooked up to a light bulb or something, okay? So, but it's not hooked up to a power supply. There's no current flowing through it initially. But what happens is it ends up in a changing magnetic field, because this guy, when hooked to an AC voltage, AC power supply, it's going to have a changing current. That changing current's going to have a changing magnetic field around it, which means it's going to induce in the secondary coil a current. Okay? And so the current, though, will be different because the number of wrappings are different. So this is the primary coil. This is the secondary coil. When an AC current flows through the primary, it has a changing magnetic field around it. That changing magnetic field is going to induce a voltage in the secondary, going to induce an EMF, going to induce a current. Okay? The induced EMF in the secondary, how big it is and how big the current is dependent upon the ratio of the turns. So if we call the voltage in the primary coil Vp and the voltage in the secondary coil Vs, then they're just going to be equal to, the ratio is going to be equal to the ratio in the primary over the ratio of the coils in the secondary. So our equation is just that simple. The ratio of the voltages will have to equal the ratio of the number of turns in each one. Okay, these are often called the number of turns or the number of wrappings. If I want a bigger voltage in the secondary, then I need to put more wrappings around here. I need to have more wrappings on this side. If I want a smaller voltage in the secondary, I need to have fewer wrappings in the secondary coil. Okay? If you take a look at your notes here in the center part, just need to make it a little smaller so it'll fit in. If the Vs is bigger in the equation, if the Vs is bigger, so if the voltage that comes out over here is bigger than the voltage we put in, then it's called a step-up transformer, because you've stepped up the voltage. And that is if Vs ends up being bigger than Vp. If Vs ends up being smaller than Vp, then it's called a step down. It's gotten tinier. Okay, so it's a step down transformer. Now, you'll often hear talk of an ideal transformer. An ideal transformer assumes no power is lost in the transformer. It assumes that the power in the primary will be equal to the power in the secondary. And if that's true, then power from grade 12 physics, so those of you that didn't have grade 12 physics, I don't know that I told you about power when we did our review, but power is just equal to the current times the voltage. So in an ideal transformer, I of the primary times V of the primary will have to equal I of the secondary times V of the secondary. So if we rearrange this and divide both sides by V of the secondary and I of the primary to get the ratio like we had up top of I primary over I secondary, we see that it ends up being, V primary over V secondary. We see that it ends up being I secondary over I primary. So we can add that to this equation up here. So N primary over N secondary will equal V primary over V secondary, but that equals I secondary over I primary. So for the first two, the P's are on the top, the S's are on the bottom. But for current, it's opposite. And it's opposite because of the power equation. Okay? So if you have any three of these four, you can find the other one. And obviously you don't ever write all six of them together. You use these two, you use these two, you use these, okay? So the other part of your homework over this wonderful, beautiful day off is I would like you to try on page 527, and it's there at the bottom of your note sheet, 527, 528. How about just trying numbers 9 to 12? And we'll leave the rest for tomorrow, okay? But numbers 9 to 12 on page 527, please. Okay, thanks muchly. See you tomorrow.